Hi guys, it's me UBprogrammer, and from today I'm gonna start a series on this Pytorch, which is a framework used for deep learning. And in this series I'll be assuming that you don't know anything about deep learning, the mathematical concepts behind it, or even the code. So if you don't know anything about Pytorch or deep learning and you wanna learn about it, you are at the right place. And we will be starting it from the very basic models, like creating our first neural network in the PyTorch, to the very end where we will be deploying our model on our local machine, or you can use any cloud service. So to follow up with this series, please subscribe the channel UBprogrammer, and let's start our
So
first
how
video.
I'll be doing this is I will not just say that you just import torch, create some tensors and you go to your network, right? Because you don't know even about tensors till now, right? So I have to create a baseline for you first. So for that I have prepared these notes, these handwritten notes for you, and these are downloadable from the description. There will be a link about it and all the source code also, so check it out. And let's start PyTorch for deep learning, right? So a simple neural network is the topic of the day, and there are five uh, underlined terms which you have to notice. And let me grab a pen and underline it now. So we have some input values in a neural network. We have some input values, right? We multiply them with some weights. These are two terms, and add them up, right? The result of multiplication, and then we pass the resultant value, the third term, through an activation function. We pass it through the activation function to get our final output. So these are the five terms, and let's see how they are contributing in our neural network. So what are the input values? These are x1, x2, x3. These are all the input values. Weights, so every input value will have its own weight in the network, right? The resultant value, what is this? This is the edge, so you can see a thread coming out of it. And what this resultant value is, it is the product of all this multiplication and then their sum value, right? So we multiply them element wise to both of them, and then we find their sum. This is our resultant value, right? And then we have our activation function, and for now just don't overthink it about it. The activation function, to make things simpler, we will just say it will define our output, right? And there can be many activation functions. We will talk about them later. And so we pass our resultant value in activation function to get our final output. This is our motive, right? To find why we are doing all this, right? And why is the output value. Okay, so let's see what we have next. So in the first step we can see we have multiple inputs, so x1, x2, x3. There can be a lot, right? And their respective weights. So w1 is the weight for x1, w2 for the x2, and so on. And to make things simpler, we can represent all our input as a one vector, then all our weights as another vector. So what will be done as this thing? So these all three inputs can be represented as a vector, and these weights can be also represented as an individual vector. So in the linear algebra we can use the application of it, application of vectors and matrices to find the product and their sum, right, as the dot product or cross multiplication, right? So this will be really simpler than we do it like element wise, right? So that's why we are using the concept of vector and matrices. And to represent these vectors and matrices in Pytorch, we use the tensors. So now we know what tensor is and why we are using it in our coding, right? So a tensor with the one dimensional is called a vector, with two or more will be called matrices, right? uh, Now this diagram can be mathematically represented as y is equal to the activation function, and it is getting some value which is the edge. This whole term is the edge, the input multiplied by weight, and then their addition. This is the summation symbol, right? And the bias. What is the bias? You just add a bias in neural network to update the working of it, right? Don't overthink about it also. So there are two things in this lecture which you don't have to overthink about. One is the activation function, the other is bias. So we will talk them about later, right? And the goal is take one step at a time. You will not understand everything in the one lecture, right? In the Pytorch language, this can be translated as y is equal to activation, right? So any function which will be using for activation, then torch dot sum, we will see about it in a bit, input multiplied by weights, then their bias added, right? Now let's see the coding part. We are ready for it, believe me, right? And I can let's start it, right? So we are importing the torch, but wait, we haven't discussed about the installation. So how you can do the installation? Just install the Anaconda, guys. Then after installing it, there will be a command in the description to make an environment. This is the environment, Pytorch environment, which I am using with the 3.7 version of Python. And if you just don't know how to do these things, environment and using the Anaconda, just text me on the WhatsApp or mail me to, I will just help you out, right? With a Zoom session, or we will figure it out, right? But first go to internet and try things out with the installation of Pytorch. Okay, so we imported Pytorch, so obviously we have to import it in order to use it, right? So import torch is the command for it. There is the activation function, right? And what this activation function is called, it is the sigmoid activation function, and it will just be using to define our output, and in the probability it is the main concept, right? But for those of you who don't know about it, just don't think about it, right? Because we will create our understanding for it, just like we did it for the tensors, right? So I will just tell you the function of or the main working of this function. So it will get any number, let's say -5, and it will bend this number into a range of 0 to 1, right? So it can't be less than 0, it can't be more than 1. So it will always give value between the, right, between a range. So on the -5 it is giving 0.0067. Let's say on the 4 it is giving 0.982. So it will always less than 1 and greater than 0. Okay, now we have what are these features, weights, bias. So features are the input, just like we have here. These are the inputs, weights obviously, and bias. Bias is here, we are defining it, right? So features are, what are these features, right? I have just initiated our input values by some numbers, right? These can be any numbers, and just think of it as a real life example, like this number can be represent number of bedrooms in a house price prediction system, right? And this can be the area of the land and things like that, right? So think of it as the real values. Then we have weights, which are respected values for every input. So if we have 5 input values, we will have 5 weights, right? And the bias will be only one term, which will be updated to improve the working of neural network. And this is the main line which we have written: y is equal to activation, right? So y is equal to activation. What is activation? This is our function, sigmoid function. Then torch dot sum and features multiply by weights, then addition of a bias, right? So in the short term, in the short language, what you can understand from this is, let's say you have some input values and you initiate some weights for it, right? So it will just create an output like this, and bias will be also initiated randomly, right? So it will create some output. Then it will compare that output with the original value, with the y and y hat, right? So and if the error is too large, then it will update these weights and these bias, and till the error become less. So this last line, if you are confused about it, just leave it. I was just explaining to some of the pros here, right? Okay, so let's wrap up our lecture number 1, and this is the first lecture, and this is the first neural network which you have built. And believe me, this is really a great start to just start learning about the Pytorch, right? And I will meet you in the next lecture.